In this video, I'm going to talk about doubly linked list and explain how add and remove method work. Let's say that we have an empty linked list. So the head is pointing at null and the tail is pointing at null. Now we want to add a node with data 20 to our linked list. The first thing that we do is to create a node with data 20 and point the previous pointer and next pointer to null. Then, because it's the first item in our linked list, simply our head is going to point at the node and the tail is going to point at the node as well. And that is how we add the first element to our linked list. Now let's say that we want to add a node with the data 5 into our linked list and we want to put it at the end of the linked list. The first step again is to make a node with data 5 and point the previous and next pointer to null. Then, because we're putting at the end of our linked list, we're gonna look at the tail and then point the previous pointer of the node that we have made to the node that the tail is pointing at currently. So the previous pointer of 5 is pointing at what the tail is pointing at. Now we're going to manipulate the next pointer of the tail to now point at 5. Now the node 5 is at the end of our linked list. The only thing that we have to do right now is to change the pointer of the tail to point at the element that we have just created. Now our linked list is formed, and as you see, the node 20 is at the head of the linked list and node 5 is at the tail of the linked list. Now let's say that we want to add a node with data -2 at index 1. The index for a linked list works like the head is going to be 0, it's going to be index 0, then the next element is going to be index 1, the next element is going to be index 2, and so on. Now let's say that we want to add the node with data -2 in index 1. So it's going to be the next element after the head. So in this case we start from the head and we're going to make the counter to be 0. Then, because the next elements in our linked list is going to be at index 1, that is the index that we want to insert our node -2. So because the counter is at 0 right now, when we're looking at the head, we know that the next counter is going to be 1, and that is where we're going to insert our element. So what we do is to point the previous pointer of the node that we have just created to point at the node that we're currently looking at. So we're going to point the previous pointer of -2 to look at 20, and the next pointer of -2 to look at the next pointer of the current node that we are looking at. So the previous pointer is pointing at 20, the next pointer is pointing at node 5. After we plug in the the node that we have just created into our linked list, we're gonna manipulate the other links as well. So in this case, we're looking at 5, and we're pointing the 5's previous to point at -2, and also we're pointing the 20's next pointer at -2 as well. Now if I rearrange the shape a little bit, I'm gonna get something like this, which is what exactly I wanted. 20 is at index 0, -2 is at index 1, and 5 is at index 3, and I have successfully inserted -2 at index 1 in my linked list. Now let's say that we want to add a node with data 32 to the back of our linked list. So because we're putting it as the last element in our linked list, we have to look at the tail first, and then say that because we're putting it at the end, now the previous pointer of 32 should point at what tail is pointing at currently, and then the next pointer of what tail is currently pointing at should point at the node that we have just created. Now in the next step, we're gonna also manipulate the tail pointer to point at the node that we have just created. So that is how adding to the back of a doubly linked list work. Now let's see that how we can remove elements from our linked list. Let's say that we want to remove the last node from our linked list. Tail is pointing at the last element in our linked list, so we are gonna look at what tail is pointing at tail is pointing at 32, then because we want to remove this 32, we have to go back one element. So we're going to go to the previous of 32, which is node 5, and then we set the next of 5 to point at null, and also our tail should change to look at 5. So we're going to also manipulate the tail pointer to look at 5. Now 32 is not accessible anymore, so basically we have removed 32 from our linked list. Now our linked list is going to look something like this. Now let's say that we want to remove -2 from our linked list. The first step that we do, if it is not from if we are not removing from tail or head, we're gonna start from the head and examine each node and continue until we find the node that we want to remove. So we start from what head is pointing at. So we're gonna ask ourselves, is this the node that we want to remove? In other words, is -2 equals to 20? It's not, so we're gonna move to the next element, which is -2, and in this case -2 is equal to -2. Then now I have to also check that -2 is at the tail of the linked list. So I'm gonna say that is -2 as the same node as tail is pointing at, and tail is pointing at 5 in this case, and -2 is not the same thing as what tail is pointing at, so I don't have to take care of any tail manipulation. So in the case that the node that you want to remove is at the tail of our linked list, you should be careful that you have to also take care of a tail manipulation. So in this case we don't need that tail manipulation, but we have to look at the next node of the -2 and the previous node of -2. So I'm looking at 20 and 5. In this case, I'm gonna point the previous pointer of 5 to point at 20, and the next pointer of 20 to point at 5. By doing that, basically I have gotten rid of -2. So as you see, if I take -2 out here, it's not going to change my linked list. The nodes that I care about are connected to each other, and as you see here, you can't access -2 at all anymore. So this is the way to remove something from the middle of the linked list. Now if I rearrange the shape a little bit, I'm gonna get something like this, which is exactly what I wanted. Now let's say that we want to remove the first element in our linked list. If we want to remove the first element, we know that the head is pointing at the first element in our linked list. In this case, head is pointing at the node 20, and node 20 is what we want to get rid of. The way to do it is to say that I go to the next node in my linked list and set its previous to point at null. Then I'll also change the head pointer to point at 5, not 20 anymore. By doing that, I don't have any link to node 20 anymore. So node 20 is unreachable, and my linked list now looks something like this.